Hi all, so we need to start with a very important topic in this lecture called as electrochemical series. It is very easy topic, in fact people make it complicated. Like, I'm very sure that if you see this video you will understand what electrochemical series actually is. By definition, what is electrochemical series? In your electrochemical series there are a lot of elements, right? Don't learn the full series. The elements are arranged in order of increasing standard reduction potential. So there will be elements here and there will be values of standard reduction potential, and they will be arranged in order of increasing standard reduction potential. And from where the standard reduction potential value is taken? With respect to hydrogen electrode, right? With respect to your hydrogen electrode. So what is an electrochemical series? The elements will be arranged in the form of increasing standard reduction potential. Now I'll not be writing the full series, just few important elements I'll be writing. I think those elements are fine for understanding what is actually an electrochemical series. So let's write here our electrochemical series in short. See, I'll be writing my reaction here, my representation here, and your standard reduction potential here, SRP. Standard reduction potential. What is reduction? Reduction is gaining of electrons, right? Oxygen is loss, reduction is gain of electrons. So let my first element be lithium. So lithium will accept an electron to give you Li. How will you represent it? E naught, Li plus is giving you Li. That's how you represent the rotation. Li plus is giving you Li, and its SRP value is minus 3.050. Okay, when you go little down, you will be finding a zinc. What happens to zinc? Zinc exists in the form of Zn2 plus. So 2 plus charge is there, so it will accept 2 electrons to give you zinc. And how will you represent it? E naught, standard, it's standard, right? That's why we are writing E naught. E naught, Zn2 plus and Zn. This has a value of minus 0.76 volt. Volt is the unit. When you go little downwards, you will have iron also. Iron exists in 2 plus here, accepts 2 electrons to give you Fe. How will you represent it? E naught. Then what is there first? Fe2 plus and then Fe, and the value is minus 0.45 volt. Now very important one now. H plus. 2 at H plus will accept 2 electrons. Like somewhere down you will be getting H plus, accept 2 electrons to give you H2. How will you write the E naught? We have studied this in your standard hydrogen electrode also. E naught, H plus and half H2. And what will be the SRP? Both SRP and SOP of hydrogen electrode will be 0. Then you go little down, you will get copper. So copper will be Cu2 plus, will be accepting 2 electrons to give you Cu. How will you represent it? E naught, Cu2 plus and Cu, and the value is plus 0.34. So see, after hydrogen the values are becoming positive. Then you go little down, you will get Ag plus, plus 1 electron is giving you Ag, and your representation will be Ag plus giving you Ag, and the value is 0.8 volt. Then you go little down towards the end, you will get fluorine. Fluorine here also fluorine exist in the form of F2 because it's a gas. So F2 will accept 2 electrons to give you Fe. Sorry, 2F minus. Accepting 2 electrons to give you F minus. So E naught you will write F2 and 2F minus. The value is plus 2.87 volt. Just remember, as you go down the series, as I am going down the series, the standard reduction potential is increasing. As I am going down, three things are happening. See, standard reduction I'll write it here. Three things are happening. First thing which is happening is standard reduction potential is increasing. Increasing, right? As we go down, the standard reduction potential is increasing. See here, it's in minus, and here, like when you go down, the values are increasing. So what does it mean? The one which is present in the lowest side, lower, like whatever is present in the lower end, they want to get reduced, right? That's why the reduction potential value is increasing. What they want to get reduced, these people, whatever are present in the lower end, they want to get reduced fast, because their standard reduction potential value is higher. So they are called to be as best oxidizing agent. See, reduction and oxidizing agent, you must be knowing in redox reactions, whatever wants to get reduced easily, they are the good oxidizing agent. So here you will get best oxidizing agents, and towards the top they want to get oxidized, so means they will be best reducing agent. Best reducing agent. So tendency to get reduced is increasing as we go down, right? Tendency to get reduced is increasing here. Tendency to either learn best reducing agent property or either learn just this one. Okay, lower end, what is happening? Your reducing power is increasing. It means it is best oxidizing agent. More oxidizing agent. So more oxidizing agent towards the end. More oxidizing agent towards the end. Okay, three things which you have to remember. That's comparatively one thing only which you should focus on, that your standard reduction potential is increasing. What does it mean? The tendency to get reduced is increasing. There will be the maximum, whatever elements are present, their tendency to get reduced is increasing. Whatever get reduced easily, that is your best oxidizing agent. So oxidizing agents will be present at the lower end of the series, and your reducing agent will be present at the top end of the series. Based on this, let's do a question. I'll do one thing. I'll just write my series here so that it becomes more easy for you to do the questions. I'm not writing the products and all here. So the question is, you have been given three elements, X, Y and Z. The value of standard reduction potential of X is 0.52, of your Y is minus 3.03, and your Z is minus 1.18. What's your question is, you have to arrange in increasing reducing power. Increasing reducing power. Increasing reducing power. First, let's do one thing. First, let us arrange them in order of standard reduction potential. Which one has lowest standard reduction potential? Okay, let's see. Which one has lowest standard reduction potential? This one, right? Y1. So Y will be here, then X, right? Both are negative, and then, sorry, here you will have Z. Z and then X, right? So this is your standard reduction potential XZY. What the question is asking? The question is asking you to arrange in increasing, reducing power. Reducing power, whatever get reduced easily. What is that? That is your oxidizing agents, right? So reduction is this way. So who will want to get reduced fast? Y1, right? So oxidizing agents will be Y, Z and then X. That's your answer. Okay, first just arrange in order of standard reducing potential. What did you get? X. You're getting X. X is the highest, Z is here and Y is here. Which means this one will be your best oxidizing agent. And here it will be best reducing agent. You have to arrange in order of increasing reducing power. Oh sorry, it's not oxidizing agent, it's reducing agent. Best reducing power, right? So best reducing power will be something which is above. So the answer will be Y, Z and then your X. Understood? One more question will do of the same manner for more clarity. The question has given you the E naught values of certain things. The E naught values are of Cr3 plus Cr is minus 0.74 volt. The E naught value of Cr2O72 minus Cr3 plus is 1.33 volt. Then the E naught value of MnO4 minus Mn2 plus is 1.51 volt. And the E naught value of Cl and Cl minus is 1.36 volt. So the question is asking you which is the strongest oxidizing agent? Which is the strongest oxidizing agent? So you know reduction happens more easily towards the bottom and the oxidation happens more easily at the top end. So upper end best reducing agents, lower end best oxidizing agents. So let us just name it as number it as A, B, C, D. How will you arrange in order of increasing SRP? Which one will come first? Whichever is lowest. Lowest is this only. So A will come, then 1.33. B will come, right? Then among C and D, D will come and then C will come. So at the lower end, you have best oxidizing agents. And the upper end, you will have best reducing agents. So who won the battle here? C. So MnO4 is your best oxidizing agent. Okay. So this is what your electrochemical series basically is. I don't think so there is any need to learn. Just remember a quick revision. It is arranged in order of increasing standard reduction potential. Only the lower end you remember. Don't get confused with the upper end also, because if you try to remember both the upper and lower, it will become more confusing. So just remember the lower end. Whatever is present in the lowest end, it undergoes reduction, and whatever undergoes reduction easily is your best oxidizing agents. Okay. Then the next topic is the application. What is the application of your electrochemical series? The first application is to find the spontaneity. To find the spontaneity of galvanic cell. So when does spontaneity happens in any kind of reaction? We studied in your one topic of spontaneity of galvanic cell. Do you remember? Delta G is equals to minus NFE naught of cell. So we just came into the conclusion, if delta G is negative or your delta E naught of the cell is positive, then only there will be spontaneity. Now E of cell, whenever it is positive, that means the cell is spontaneous, right? How does your E naught of cell will come? E naught of the cell will come as, we know the formula, right? E naught of cell equals to E naught of cathode minus E naught of anode, right? This was the formula to find the standard electrode potential. Now, you must be remembering that electrochemical series which we just now studied. There were some numbers towards the above portion which were in negative value. The middle portion was 0 hydrogen, and towards the end you're increasing. It was increasing, right? You were getting positive values, right? So it's logical, like if you want to get E naught cell as positive, what you have to do, your E naught cathode should be greater, right? Like logically E naught cathode should be greater than E naught anode. What does it mean? Like if I take, like just random value, if I take E naught cathode as 10, E naught anode value as 6, then only I'll get a positive value, right? But if I take E naught anode as 10 and E naught cathode as 6, I'll get a negative value, right? Minus 4. This I don't want. I want a positive value. For getting a positive value, my E naught cathode should be greater than E naught A. What does it mean? The cathode selection will be from that end of the electro series which contains more positive. So means cathode should be present downwards in the series, and anode should be up. So anode selection should be from the up and cathode selection should be from the downward side. Okay. So understood the logic? Because we want E naught cell to be more positive, E naught cathode should be positive. So cathode selection should be downward from the series, anode selection should be upward from the series. Okay. So one question I'll ask you is, just go through your electrochemical series again and tell me which one should be the anode and cathode. Which one should be anode and which one should be cathode? The question is of copper and zinc. I'll tell you the electrochemical values also of copper and zinc. Copper was plus 0.34 and the zinc value is minus 0.76. So if you have understood the previous topic, you know E naught of cathode should be greater than E naught of anode, right? So which one will be cathode here? Copper will be my cathode and zinc will be my anode. Anode undergoes oxidation in a galvanic cell and cathode will undergo reduction. Okay, this is my first application. Second application is to check which metal will liberate hydrogen gas. Just remember, metal above hydrogen. Metal which are above hydrogen displaces hydrogen. Displaces H2 from dilute mineral acid. Like for example, I am writing my series again, like not a proper series, but I am just randomly writing Zn, then Fe, then your hydrogen is here, copper, Ag and Fe. Now I am telling you, will zinc replace hydrogen from H2SO4? And my next question is, will copper replace HCl? Will they give hydrogen gas or not in the reaction? Zinc, where is zinc? See, first look at your hydrogen. Hydrogen is here. Where is zinc? Zinc is above. So whatever is present above hydrogen will replace hydrogen. So it will become ZnSO4 plus H2, copper plus HCl. So this one will mean this cell reaction is spontaneous. Okay. Now here you can see if zinc is in 0 oxidation state, here plus 2 oxidation state. So zinc is undergoing oxidation, hydrogen is getting reduction. So whatever is undergoing oxidation will be your anode, and whatever, like, just remember this term, lone. Anode, and whatever is undergoing reduction is your cathode. Okay. Now in this reaction happens, but it is non-spontaneous. Here the things are spontaneous. Why? Because your zinc lies above hydrogen. But in this case, the reaction happens, but this will be non-spontaneous. Why? Why? Copper lies below hydrogen. Okay. So copper should have been cathode. That's why this reaction is non-spontaneous. So I hope everything is clear from this electrochemical cell. Galvanic cell, just revise the topics again, and just remember, in galvanic cell we are using the term lone only in galvanic cell or electrochemical cell. Left side oxidation anode is negative only in galvanic cell. Next topic will be covering electrolytic cell, where exactly the opposite happens. Okay, so I hope we meet in the next video. Thank you so much.